If you remember, the other day we did absolute value equal to 5. It had 2 answers, and today we're only looking at positive inequalities. We're only looking at our number on the right being positive. The special cases of 0 and negative numbers is something that very likely will be addressed on the ACT, and I probably have some worksheets on that, so I think we'll need to spend some time with it before the ACT. Now look what happens if you think about it. Normally we solve it and then graph it, and when you do inequalities, you are interested in many solutions. If it has solutions, and we will do the ones that do have solutions, the classic, we're just looking at classics. That's probably the best way to tell you. And I'm going to go ahead and do a number line, something like this, because this is one where you kind of approach it more from the graph and then backwards. Because I'm interested in the numbers that would work in here. Now remember, absolute value is of a positive number is the same number. So if I'm looking at numbers that are greater than or equal to 5, will 5 work? Is the absolute value of 5 equal to 5? It is. What about 6 and 7 and all of those? They will work. Now what about 4? Let's test some of these in here. Will 4 work? Will 0 work? Is the absolute value of 0 bigger than 5? No. Absolute value of 4 greater than 5? No. And even on the negative side, absolute value of negative 1 is 1, and that's not bigger than 5. And that's probably not a very good place for my tick mark. I try to make them, whatever you make your scale, make it look like it's to scale. You know, if you're going to do 2, 4, 6, 8, if you can do 1, 2, 3, 4, that's great. But if I've got wide, you know, if my numbers go from negative 5 to 5, I'm probably not going to put 10, 11, 12 tick marks. And so what happens over here is the absolute value of negative 5 will work because that puts the equal part. And then the 6 will work, negative 6 will work because its absolute value is positive. And so what you end up with is a statement that says that x, if you remember from doing this kind of with domain and range, this side is x is less than or equal to negative 5, or this side is x is greater than or equal to 5. It is or because there's no number that's over here and over here at the same time. Now there's going to be some great little silly clues to help you do these, but they work. And I've never seen anything else that makes it any better, and they're kind of silly, but it does work. Now let's do the other direction. Let's just do the absolute value of x. Let's pick a fairly easy number. Let's do less than or equal to 2. That's an easy number line. So I'm going to put 0 in the middle. I'm interested in 1, 2, 3. I'm interested in negative 1, negative 2, negative 3. Now these are going to be the ones you graph before, because it's the same thing. You got to get your absolute value by itself. The number is going to work. I did set it up to where 2 will work and negative 2 will work. Now sometimes those will be open dots because they won't work. Now where are the numbers that work? Where are the numbers over here on the positive side whose absolute value are smaller than or equal to 2? Do you see it's going to be not 3? 3, absolute value is 3, less than or equal to 2. No, these are false. You know, these are the false ones. These are the true ones. These are the false ones. These don't work. And negative 3 is not going to work. So the true ones are in here. Absolute value of 1 is 1. It's less than or equal to 2. 0. 0 is less than or equal to 2. So your numbers, and this is actually a between statement. We'll come back and write some of that here in just a minute. And what happens, you can actually write, and I'm going to put it underneath. I didn't leave myself enough room. You can write it 2 different ways. You can say x is, I'm going to actually write this as an and statement, and I've seen it both ways on the ACT. It's x is less than or equal to 2 and greater than or equal to negative 2. It has to meet both conditions because x is less than or equal to 2 would include negative 3, but negative 3 doesn't work for this one. It has to be between these numbers. I prefer, and most math teachers prefer, like we did with domain, is the between statement from negative 2 on the left, just like a number line, and then to positive 2 on the right of what numbers. And it's really, you are doing the domain of it. What x's will work. So that's why it looks like domain. let's go ahead and give you the rules that I use that help me remember, because it would be hard for me to remember. You're already thinking, oh, I gotta know which ones are ors and which ones are ands. And when they're classics, when these numbers are positive, when your absolute values by itself, the classic greater than is always going to be an outside statement, outside graph. That's what I call this. So if you hear when you say this, you say greater, and see the kind of has that greater sound. And so we think of or, and then it's an outside graph. And by outside, I mean shading from the inside out. Sorry, there you go. I don't know why I wrote it up there, but I guess that was as good a place as any. I should have written it down here. But if you'll think greater than, greater, I mean, I don't know where I came up with that, but it works. Now, there's no trick for the less than, but you just have to remember it's the other. So less than is going to be your and it's going to be shaded between. So there's really no tricks on that one. So you just kind of have to remember greater than is or, outside, then the less than is and it's inside. You can say between or inside. Okay, let's try one. Absolute value of 3x minus 5 is greater than 4. Now I want you to notice a couple of things. When we did, remember how in inequalities we would write our two statements that were equations? And we would always copy the original and take the bars off of it. That would get the equation as if it were not absolute value. And then we have to consider the other side of it, and we would take it to the equal to the opposite of that one. Well, with these, you already see it greater than, so I know it's or. Okay, so I know it's going to be shaded like this. So this side of it is going to be what this would be without absolute value bars. It's going to be 3x minus 5 is greater than 4. You're just going to copy it like it is, and that will graph a point and a ray. It'll graph one end of a graph. It'll either graph this end or that end, and it's going to graph another end of it. It's going to graph your two outside graphs. Now, what do? Look what we did. This was the first one. We copied it. This is the second one. You noticed your inequality reverses, and you noticed your number is opposite. So this is going to get that negative side of it. The 3x minus 5 will be less than the negative 4. It's got to be on the other side. See, that gets you outside this way. That gets you outside this way. Now you just solve them like regular inequalities. Add 5, greater than 3. Okay, this one, add 5, and I get 3x is less than 1. X is less than 1/3 when I divide by 3. Okay, graph. Now I've got to have a graph that 1/3 is on and 3 is on. So I'm going to do, and we don't put fraction. I mean, if you want to put it on there after you've done your integers, I don't like tick marks that are just 1/3, 2/3 like that. So I'm going to do 0, 1, 2, 3, and I got room for 4, so I'll put 4 there. Now you have to wrap your head around, or it's going to be outside graph. We'll graph this one just like it says it. X is greater than 3. Is that open dot or closed dot? Is 3 true? Is 3 greater than 3? No. To show it's false, it has nothing above it. No solid dot. So 3 would be false. All of these would be false for that one. And all of these are true for this one. So there's your true for that part. Now where's 1/3? What two integers is it between?
0 and 1.
It's between 0 and 1, and I just need it eyeballed. Half, so it's going to be a little less than half. It, again, is not equal to 1/3, sorry. Not equal to 1/3. It's an open dot, and everything's smaller than that. So, in this case, any number you pick in this area will work. It makes that one true. Remember, or, you only have to make one of them true. So, these points make that one true. These points make that one true. And it only has to be one of them. There's no number that makes both of them true. There is no number that's bigger than 3 and also less than 1/3. absolute value of, let's see, I need to write or outside here. And you don't want to make that a decision until you have your absolute value by itself. Is plus 5 is less than or equal to 37. Absolute value, anytime you're doing something with it, has to be by itself. So we're going to have to move that 5, and we get the absolute value of 8n minus 2 is less than or equal to 32. So less than is and it's going to be a between graph. Copy it as it is. an minus 2 is less than or equal to 32, and it has to meet both conditions. 8n minus 2 is greater than or equal to negative 32. This gets your right side. That's going to get your point on this side, and then this one's going to get your point on the left, and it's a negative there. You can't see that negative very well. Negative 32. Okay, you get 8n is less than or equal to 34. Divide by 8, you get n is less than or equal to 34 over 8. Now, probably here, you're definitely going to want to reduce it. It's going to be 17 over 4, but that doesn't tell me exactly where it is on graph paper. So I'm going to write it exactly 4.25, or you can write it 4 1/4, but you need to know where it is. When I add 2, I get 8n is greater than or equal to negative 30. Divide by 8, n is greater than or equal to negative 30 over 8, which reduces to negative 15 over 4. As a decimal, it is negative 3.75. Mixed number, it's negative 3 3/4. Then it's going to be all the numbers in between.